Our group has elected to undertake the competitive challenge, which analyses the historical price of Bitcoin. Bitcoin is a type of cryptocurrency renowned for its volatility. This time series will be modelled using regression, ARIMA, and GARCH methods. This presentation details a description of the time series, model specification, model fitting and selection, diagnostic checking, and predicts the value of Bitcoin for the following 10 days. The plot shows the daily closing price of Bitcoin from the 27th of April 2013 to the 3rd of March 2018, given in US dollars. The main characteristics of the time series are a change in trend at the beginning of 2017, a change in variance with large spikes in the price at the end of the time series, and autoaggressive behaviour. A flat trend is observed from the start of the time series to early 2017. The flat part of the time series is removed to better model the later part of the time series, which shows a change in Bitcoin price. So the plot now starts from the 1st of April 2017. The main characteristics again are a change in trend, change in variance, and autoaggressive behaviour. The scatter plot shows the relationship between the consecutive points to determine the presence of autoaggressive behaviour. A correlation index of 0.9935 was calculated. This is indicative of a strong positive correlation between neighbouring Bitcoin values and in turn the presence of autocorrelation. The plots give the regression models for the linear and quadratic trend lines. Both models are statistically significant with the same p-value, and they both also have a similar adjusted R-squared value of 0.7119 and 0.7198 for the linear and quadratic models respectively. With similar results, the more conservative linear model is preferred. The panel above gives a time series plot, ACF, and histogram of the standardized residuals for the linear model of the Bitcoin time series. The plot to the right shows the normal QQ plot of residuals. The linear model does not pass these diagnostic checks, and the linear model does not capture all the information in the time series, so is not suitable for forecasting. The uppermost plot in the panel shows points in the time series with a trend and change in variance. The ACF plot shows a slowly decaying pattern with many significant lags. There is no indication of a wave or sine pattern, so that a seasonal component is not determined. The PACF plot shows a first significant lag with four small significant or near significant lags. The time series needs to be stabilised and detrended prior to specifying a set of possible ARIMA models. Calculation of the log likelihood for each lambda value using the Yule-Walker method gave a lambda value between 0.1 and 0.2. A Box-Cox transformation was applied to stabilise the time series. One differencing was applied to detrend the time series. The uppermost plot in the panel shows the result of the transformation and differencing. Dickey-Fuller unit root test gave a p-value of 0.01. Thus, the null hypothesis is rejected, and in turn, the time series is determined to be stationary. The ACF plot shows 2 significant lags, and the PACF plot shows 5 significant lags. However, the fifth is around lag 80, so is not included. So from this, the ARIMA 412, ARIMA 312 are included in the set of possible models. The EACF plot shown above identified possible smaller ARIMA models with a p-value of 1 and 2 and a q-value of 1 and 2. The BIC plot given above right identified possible larger ARIMA models with a p-value of 4 and 5 and q4. P10 was disregarded with smaller values identified, so that ARIMA 111, 112, 211, 212, 414 and 514 are added to the set of possible models. The ARIMA 514 was the only model to show all significant parameter coefficients with the CSS method, but none with the MLE method. The table far left shows the sorted ACI and AIC and BIC scores However, the AIC and BIC functions identify different models as best, with ARIMA 312 and 111 given respectively. The table above right shows the calculated parameter coefficients for the ARIMA 312 model. The CSS method showed AR1, MA1 and MA2 components to be significant, while the MLE method showed AR1, AR2, MA1 and MA2 components to be significant. It has an MASE of 0.989. The calculation for parameter coefficients for the ARIMA 111 model returned NA values. The plot of residuals shown uppermost in the panel above shows residuals scattering around the mean zero without a pattern. The histogram shows an approximately symmetric distribution around zero, and the ACF do not show a pattern, although there are two significant lags which may indicate some autocorrelation in the residuals. The QQ plot of residuals given to the immediate left shows the points plotting along a straight line with only a few points deviating at either tail. The Lung box test shows all the residuals above a p-value of 0.05. The residual analysis of the ARIMA 312 indicate the model has captured the information in the time series. The plot shows the original time series for the historical price Bitcoin. A prediction of the following 10 days is given with the ARIMA 312 model. The forecast shows a steady Bitcoin price with possible increase or decrease within the range of confidence interval 80 and 95% bounds. MASE between actual and predicted value is 3.233. That is 3 times more than the original model. ARIMA model is not suitable for accurate prediction of daily closing prices for Bitcoin. The McLeod-Lee test is significant at 5% level of significance for all lags. This suggests the existence of volatility clustering. From absolute value transformation, we observe many significant lags in both ACF and PACF. EACF do not suggest an ARMA 00. EACF we can identify ARMA 10, 11 and 21 models for absolute value series. Proposed GARCH models are GARCH 01, 11 and 12. In conclusion, regression models are not suitable for daily Bitcoin closing prices. A ARIMA model is good, but the mean absolute scaled error of 3.2 is not practical for prediction. ARIMA models are not suitable as they are unable to capture high volatility in the series. A combination of ARIMA and GARCH prediction models can be better used for the daily prediction of Bitcoin closing prices.